Good morning, friends. Today we have discussed hydraulic pneumatic, unit number 6, system design of hydraulic and pneumatic circuits. See, in previous lecture we have seen the programs on hydraulic circuits. So design the system of hydraulic and pneumatics. So this is next program. Write down statement. Machine slide is moved by means of hydraulic cylinder. Full stop. The machine slide is moved by means of hydraulic cylinder. The motion of the cylinder is as follows. Initially, it moved through a distance of 200 mm and against a load of 12 kilonewton in about 3 seconds. It is followed by a working stroke of 100 mm against a load of 12 kilonewton in about 3 seconds. B. It followed by working stroke of 100 mm against an effective load of 35 kilonewton. The feed rate during this part of stroke is required to be between 0.50 to 1 meter per minute. C. The return stroke is to be as fast as possible. A meter out circuit type is used for speed control. Draw a hydraulic circuit which will fulfill this requirement. Select all the different components used in the circuit from the standard data tables. Mention their rating. This numerical we have discussed in previous lecture. So today we have discussed here this numerical machine slides. So write down this numerical. A machine slide is moved by means of hydraulic cylinder. The motion of cylinder is as follows. First, initially it moved through a distance of 200 mm against a load of 12 kilonewton in about 3 seconds. B. It followed by working stroke of 100 mm again an effective load of 35 kilonewton. The feed rate during the sport of the stroke is required to between 0.50 to 1 meter per minute. Use regeneration for retraction. Meter in circuit to be used for speed control. Draw and design the hydraulic circuit. Mention the selection requirement of flow control valve, check valve, pressure relief valve, pump, strainer, and reservoir. So this is given in program. Write down program or read carefully. So write down what is given in this program. So draw firstly meter in type, fast approach, slow working, and fast return circuit. So see here, this is workpiece here, cutting tool, machine table, dissection wall, DCV, 4x2 DCV. This is motors and pressure PRV. So this is metering circuit. Metering type of fast approach, slow working, and fast return circuit. In this question, it has been asked to use regeneration for retraction, but regeneration for retraction is not as well as possible. When the rig up the circuit for regeneration, the cylinder will extend due to the difference in the effective area between piston side and rod side. The effective area on piston side is more than on the rod side. Hence, the net force causes the piston to move in forward direction, causing extension of the cylinder. Regenerative extension is possible, but not regenerative retraction. Speed during approach, V1 equals to stroke upon time, 200 mm upon 3 seconds. 0.2 upon 3 meter per second, 0.066 meter per second. Force during approach, F1 equal to 12 kilonewton, 1200 Newton. Speed during working stroke, V2 equal to 0.5 upon 60, 1 upon 60 meter per second, 0.0083. Force during working stroke, F2 equal to 235 kilonewton, 35,000 Newton. This is called deceleration circuit. From the table of the pump are available for maximum pressure of 70 bar. So we shall start with assumption of P equal to 70 bar. Design of the system. Step 1, selection of cylinder. First, during approach, D equal to under root of 4 F1 upon pi P equal to 4 into 12,000 upon pi into 70 into 10 raised to 5 equal to 0.0467 meter equal to 46.72 mm. During working stroke, D equal to 4F2 pi P equal to 4 into 35,000 pi into 70 into 10 raised to 5 equal to 0.0798 meter, 79.8 mm. From the table of cylinder, cylinder A5 is selected, bore diameter D equal to 100 mm, rod diameter D equal to 50 mm. Selection of vane pump. Pressure during approach, P1 equal to F1 upon A, 4 F1 upon pi d square. P1 equal to 4 into 12,000 upon pi into 0.1 square, 1527887 Newton per meter square, equal to 15.28 bar. Discharge during approach, Q equal to A into V1 pi d square upon 4 into V1, Q1 equal to pi into 0.1 square upon 4 into 0.0667 equal to 0.005236 meter cube per second equal to 31.41 liter per minute. Pressure during working stroke, P2 equal to F2 upon A, 4 F2 upon pi d square, P2 equal to 4 into 35,000 upon pi into 0.1 square, 44.56 338 Newton meter square, 44.56 bar. Discharge during working stroke, Q2 equal to A into V2 pi d square upon 4 into V2, Q2 equal to pi into 0.1 square upon 4 into 0.5 upon 60 to pi into 0.1 square upon 4 into 1 by 60, 0.000654 to 0.0001309 meters cube per second, 3.92 to 7.85 liter per minute. So discharge required is 31.41 liter per minute at 15.28 bar, 7.85 RPM at 44.56 bar. From the table of vane pump, pump P5 is selected. It has 37.5 liter per minute at 35 bar and 35.6 liter per minute at 70 bar. Maximum discharge of this pump is 39 RPM at 0 bar. Selection of oil reservoir. Capacity of reservoir should be more than 3 times the maximum discharge. Capacity of reservoir greater than 3 into 39 liter per second, greater than 117 liter per second. From the table of cylinder, reservoir model T3 is selected. It has capacity 250 liters. Speed during retraction, Qmax upon A, 39 upon 60,000 into 4 upon pi 0.1 square minus 0.05 square equal to 0.11 meter per second. Selection of other component. Maximum pressure in the system is 44.56 bar. Maximum discharge in the system is 39 RPM. For this value, the following components are selected. Table number 4, serial number 1, component strainer, model S2, pressure range dash, flow rate range 76 RPM. Table number 5, serial number 2, pressure component pressure gauge, model PG2, pressure range 0.40 bar, flow rate, no flow rate. 6, relief valve, table number 6, component relief valve, model R4, pressure range 105 bar, flow rate range 57 RPM. 7, flow control valve F4, 70 bar, 0.24.6 RPM. 8, direction control valve D3, 210 bar, 76 RPM. 9, table number 9, component check valve, model C3, pressure range 210 bar, flow rate range 76 RPM. Flow control valve for 39 RPM is not available in the table 7 of flow control valve. Hence, the biggest among the available ones is selected. This is model F4 is selected. So in this way, we have seen this problem and solved this problem. So any doubt, any queries, please ask me. So we are discuss about this problem, very simple problem. We can see here. See, in this questions, this is metering circuit. So see here, in this question, it has been asked to use regeneration of for retraction, but regeneration for retraction is not at all possible. When we rig up the circuit for regeneration, the cylinder will extend due to the difference in effective area between piston side and rod side. The effective area on piston side is more than that on rod side. Hence, the net force causes the piston to move in forward direction, causing extension of the cylinder. Regenerative extension is possible, but not the regenerative retraction. So in this way, we have seen this problem. We have select all this design, this component, direction of other component. So start. Today we have stopped here. Any doubt, any queries, please ask me. In the next lecture, we will discuss another problem on system design of hydraulic and pneumatic circuit. So today we have stopped here. Thank you.